This tutorial is called Reductions and Enlargements, and we're looking at scale drawing here. Okay, so using scales, we're reducing things or enlarging them and drawing them on paper using scale. Now this is very important you understand this fact, is that when we look at a scale, so example of 1 to 100 or 1 is to 50, the drawing size is always on the left. So the number on the left is the drawing size, and the number on the right hand side of the ratio there is the real size, so the original size in real life. So you need to remember that as you do your calculations and things. Let's look at reductions firstly. Reductions are the most common type of scale drawing or scale map that you will use, because what we're doing is we're reducing the real life size and scaling it right down and reducing it right down so it fits on a piece of paper. So we usually deal in reductions when we look at scale maps. And here's an example of a reduction, a very simple example. 1 is to 2. So the drawing size is 1 compared to the real size of 2. So that means we can actually make a fraction here now. The drawing size is half as big as the real size. That's what it means. Okay, so the drawing would be half as big as what it is in real life. Here's another example, 1 is to 500. In this case, we've reduced it right down to 1/500th, okay, as big as the real size. So it gives us a fraction, 1 over 2, or 1 over 500. And so what we do is we get the real size, and in the first case, we divide it by 2 to get our drawing size. In the second case, we get the real size and we divide it by 500 to get our drawing size. So it's giving us a fraction or a division to do. That's reductions. Let's look at enlargements now, the opposite case. So enlargements are things like, say, in a microscope, when you're blowing things up, enlarging them so you can see them clearly if they're small. So 2 is to 1. In this case, the drawing size is 2 and the real size is 1. So what that means is the drawing size is twice as big as the real size, or double. Okay, so the drawing is twice as big because the drawing's always on the left-hand side of the ratio. Or if you look at 500 to 1, the drawing's 500 times bigger than the real size. Okay, so that's how the scale works. The left-hand side is the drawing, and the right-hand side is the real or original size. It's important you know that when you're doing your calculations and drawings. Okay, let's have a look at question 1. Measure the line, then draw a copy at 2 is to 1. There's the line. Press pause, measure it now, and then draw the copy at a size 2 is to 1. Okay, so we measure it carefully with our ruler. We do need to measure these quite carefully. I get a measurement of 6 centimetres. Just keep in mind when we're doing this unit that when you print things out and photocopy them, sometimes it can be slightly distorted. So when I've measured it at 6 centimetres, but when you get your photocopy, it should be close to 6, but hopefully it's exactly 6. So if there's any little issues with the measurements that I give, if you're slightly different when you measure it, that could be because of photocopying. Anyway, we've got 6 centimetres. Now we need to draw a copy at 2 is to 1. Okay, so what does that mean? The drawing to the real, 2 is to 1. So the drawing is twice as big as the real size. The real size was 6, so we're going to double it because it's twice as big. It's going to be 12 centimetres. And there's our copy, or our line, at a scale of 2 to 1 is 12 centimetres. So hopefully you drew a line that was 12 centimetres. That would be the correct answer. Okay, question 2. Measure the rectangle, then draw a copy at 4 is to 1. Okay, so there's the original rectangle. Measure the length and the width, and then draw a copy at a scale of 4 is to 1. Okay, so measuring it, it's 2.5 centimetres length, and the width is 1 centimetre. That's our original, or our real size. Okay, let's draw a copy now at a scale of 4 to 1. So that means that the drawing is 4 times bigger. So the length is going to be 4 times bigger and the width. Okay, so there it is there. The length is 10 centimetres, our copy. It's 2.5 originally, but 4 times bigger gives us 10 centimetres. And the width is 1 centimetre originally, but times it by 4, we get 4 centimetres. So you should have drawn a rectangle that was 10 centimetres long and 4 centimetres wide. Okay, question 3. Measure the line and draw a copy at 1:3. There's the line, measure it, press pause, and then draw a copy at 1:3. Because just like our first line in question 1, it's also 6 centimetres. Now we need to draw a copy at 1:3. So the drawing is actually 1 and the real size is 3. So this is a reduction. So the drawing is going to be 1/3 as big, so 1/3 of 6 centimetres. To work it out, you could just divide by 3. If you're using thirds, you're dividing by 3. So 6 centimetres divided by 3 equals 2 centimetres. So your line in the answer should be 2 centimetres long. Question 4, final question. Measure the rectangle and draw a copy at 1:5. There it is there. So measure it, press pause, and draw your copy. Okay, I've got 5 centimetres and 2.5 centimetres as the measurements for the rectangle. Drawing to real, 1:5. So the drawing is 1/5 as big. When we're doing fifths, we're dividing by 5. So the length is 5 centimetres originally, divided by 5 is going to be 1 centimetre. It's going to be a small drawing, this one. And the width was 2.5, again divided by 5 equals 0.5 centimetres. So it's a tiny little rectangle, 1 centimetre length and 0.5 centimetres for width. Okay, so that was that worksheet there. It's time for you to try it out and then keep going in your activities.